In this video, let me tell you about another type of orthogonal matrix that's called a permutation matrix. So a permutation matrix is a n by n matrix, which when you multiply another matrix, multiply it against another matrix, you permute the rows of the matrix. So I can show you for 2 by 2 matrices. So 2 by 2. If we write down the order of the rows of a 2 by 2 matrix, the usual order would be row 1, row 2. But you can then permute the rows. So you can put row 2 first and then row 1 second. So if you permute the rows, you would have 2, 1. So that represents the row order of a 2 by 2 matrix. So the permutation matrix that you multiply this 2 by 2 matrix by that keeps the same order is just the identity matrix, right? So the identity matrix is also called a permutation matrix. What about the matrix that reverses the order? Well, I think I'll show you that the 2 by 2 matrix will look like 0, 1, 1, 0. Okay? We can try that out just for fun. So we can have 0, 1, 1, 0. We multiply general 2 by 2 matrix. Then we would get 0 times A plus 1 times C. So we would have C, D, and then A, B. Right? So all we've done here then is to permute the rows. Okay. What if we multiply on the right? Okay. Remember, matrix multiplication doesn't commute. So A, B, C, D, 0, 1, 1, 0. What would we get? We get B. Right, so 0, B, and then A, B, A times B, A. And then we get D, and then we get C, okay? So I did some torturous multiplication there, but actually it's kind of trivial. All we've done is permute the columns, okay? So a permutation matrix, when multiplied on the left, permutes the rows. When multiplied on the right, it permutes the columns of a matrix. Okay, what about the 3 by 3 case? Well, how many different ways are there to permute the rows of a 3 by 3 matrix? Right, we can write down all of them. So 1, 2, 3 means that there's no permutation. And then we can permute the second and the third row. So that would be 1, 3, 2, right? And then we can put 2 here, and then a 1 and a 3, right? So we're permuting the first and the second row. And then we can have a 2, 3, 1, okay? 1, 2, 3, 4. And then we can put 3 first, and 1 and 2. And then 3 and 2 and 1. Okay, so these are the 6 permutations of a rows of a 3 by 3 matrix. And that is just 3 factorial, right? You have 3 choices of what to put in the first row, 2 choices of what to put in the second row, and 1 choice of what to put in the last row, so 3 factorial. So there are, in fact, 6 different permutation matrices in the 3 by 3 case. So you might think it's hard to determine what are the permutation matrices, but actually it's quite simple, because if we write the permutation matrix times A in this rather clever way, we can write that as the permutation matrix times the identity matrix times A. So if the permutation matrix is the matrix that permutes the rows of A, then the permutation times the identity matrix is just commuting the rows of the identity matrix, and that multiplies A. So these 6 permutation matrices are just the 6 matrices you obtain by permuting the rows of the identity matrix. Okay, very simple. The rows of the identity matrix is an orthonormal, orthogonal matrix, and the identity matrix with the rows permuted is also an orthogonal matrix. So the permutation matrix is orthogonal, okay? Preserves norms of vectors. Clearly, if you have a column vector and you change the rows of the vector, you don't change the length of the vector. Okay, so in this video, we talked about another example of orthogonal matrices, the permutation matrix. It's actually quite simple because the permutation matrix is just the identity matrix with its rows permuted. I'm Jeff Chasnov. Thanks for watching, and I'll see you in the next video.